In this demo, I'll be showing you what the map combinator is and how it can be used to easily transform data within your code. I'm going to start with this first function here. It returns an optional i32 value. I have the function body hidden, so we don't know if it returns some value or if it returns nothing. My program will be one that takes this number and just adds 1 to it. I'm going to write this program as we have been using match expressions. In our program, we have a variable named +1, which is an optional value. We are matching on maybe num, which returns an option, so we need to account for both having a value and not having a value. If we do have a value, we'll assign the value to the variable named num, and then we'll also return an optional value with the number +1. So that'll give us our number +1. If there's no number there, we'll just return none. As you can see, this is a lot of code just to get a number +1. It seems a little bit long-winded, and we can fix this by using the map combinator. When working with data, when you transform something from one thing to another, it's called mapping. So we're mapping one value to another value. In this case here, we are mapping number to be the number +1. And we can use the map combinator to do that for us. I'm going to rewrite this code to use the map combinator. So we'll have our same variable name. We're going to call the function just as we did before. And now we're just going to call the map function. The map function is an implementation on option, so it's available for us to use. The map function accepts a function to operate with. So I'm going to use a closure. Closures are created using vertical bars or pipes with arguments in between the pipes. The arguments for this closure will be the inner value of the option. In this case, the argument will be an i32. I'm going to give it the same name I gave before, which is num. And then for the body of the closure, I'm just going to return num +1. Remember, with closures, it's similar to a function. So here we have our argument to our closure, and here is the body of our closure, and it's going to automatically return this number +1. This number is the inner value of the option. So we've condensed all this code into this part right here. The great thing with map is it will only apply if there actually is a value there. So if we use map and the option happens to be none, then none of this code gets ran, just like with our match block. In addition to transforming this here, we can also create an entirely new type. Let's use this maybe word as an example. I'm going to delete this code, and I'll write a new program that calculates the length of the word. And just like that, we have transformed a string into an integer, because the .len function will calculate how many characters are in the string. And so now the return value of that will be an integer, and so the word length will be an optional integer. One thing to note with map is eventually you will have to perform a match operation because this word length here is still an optional value. So if I add some type annotations, we can see that the value is actually an option. So at some point you will have to match on this. But you're able to use map to easily work with the value, and you don't have to use match or if expressions beforehand. The last thing I'd like to note is that map can be chained. So we can call map multiple times. So if we wanted to take the word length and multiply that by 2, we can do so like that. So now we have the may optional string. So maybe word returns a string wrapped in an option. We then map that string into the length of the string. And then we take the length of the string and we multiply it by 2. Performing maps in this fashion allow you to easily work with optional data, and you can transform it from one piece of data to another, and you don't have to have all the code to check to make sure that you actually have the data. You can just keep chaining map over and over again until you eventually get to the data type you need, and it's all completely encapsulated within a single variable. This concludes the demo on mapping. I'll see you in the next presentation.